Hello my students, that's me, Bishr Samhan, chemistry teacher. Today we will start within Unit 5, Edexcel board, International Advanced Level, Edexcel Pearson International Advanced Level for October 2023 paper. Okay, first of all, we are going to the multiple choice questions. The first question is, which of these is a D block element, but it is not a transition element? The definition of the transition element, which has D orbitals, which they are partially filled. If you return back to the periodic table, you will find the following. All these elements, cobalt, copper, nickel, they will form positive ion with partially filled D orbitals. But for zinc, zinc has the electronic configuration, or the atomic number of zinc is 30. If we use the abbreviation method, it's R, AR, argon, and then we have 4s2, 3d10. So you have full filled D orbitals for zinc. When the zinc positive 2 is formed, it's the most stable ion for zinc. The 2 electrons from s orbital was lost. So the electronic configuration for zinc positive 2 is like that, 3d10 orbitals, and then you will find that the d orbitals, they are 5 orbitals, they are full filled with electrons, like that. You will see, okay, we have fulfilled electrons, so it will be 1, 2. You shall apply the Hans rule when you fill the electrons in the orbitals. So we have 10 electrons in 3d orbitals for zinc positive 2. So the element which has full d orbitals is the element that form the positive 2 ion with fulfilled d orbital is zinc. Okay, now next one. In which of these pairs does the transition metals have the same oxidation number? Okay, if you return back, or if you calculate the oxidation number of a chromium there, it will be positive, how much it is? Positive 2 times negative 2 for oxygen. It's negative 4 plus negative 2 of 2 chlorides. So it's negative 6. So here it's positive 6. Okay. So positive 6 oxidation state. For a chromium there, it is neutral for ammonia. The charge of ammonia is a neutral. And this chloride, they are 2 species with negative 2. So you will see that the positive charge for the total positive charge for the complex ion is positive 1. So the charge of a chromium there is negative 2 plus. So it's positive 3 because it cancelled with negative. So they are not the same. So we have a chromium positive 6 and the chromium positive 3. So this is not the case, which they are not changed. For part B, the oxidation number of copper there is positive 1, since ammonia is neutral. And for copper there, it is positive 2. Also, they are not equal, so this is not the case which they asking about. They have the same oxidation number. For manganese there, we know that oxygen has negative 2. So 3 times negative 2, it's negative 6 over 2. It's positive 3 there. And here it's positive 4. So both are not equal also. In the last one, you will see that the total charge of vanadate ion, or both vanadium ions or vanadium polyatomic ions, the first oxidation state for vanadium, we are talking about 3 times negative 2 for each oxide, so negative 6 to the other side. It will be negative 6 plus, it is positive 5 there. Okay. And here we are talking about positive 5 also. So in both cases, in both ions, the oxidation state of vanadium is positive 5. So D is the correct answer. For next question, question 3, what is the coordination number of chromium in the complex ion? Shown. He's asking you what is the coordination number. The coordination number is identified by how many covalent bonds, how many dative covalent bonds. You will find So 1, good. It is, let's change the color. We have 1, 2, 3, 4, 5, 6 coordination numbers. So you will find that 6 dative covalent bonds. So the correct answer is 6. Now, for next question. Here we have aqueous sodium hydroxide and aqueous ammonia are added until they are in excess. To separate the portions of pale green aqueous solution E. The test which is done is aqueous sodium hydroxide is added to E, and then green precipitate forms. No further change is in excess. And when the aqueous ammonia is added to E, the green precipitate forms. Green precipitate dissolves in excess to form pale blue solution. So for the first test, if we thought that it is copper, so copper will form pale blue precipitate with sodium hydroxide, so copper not works. And if you return back to the solubility, okay, so it will not be iron because it will form soluble one with ammonia. So nickel is the most suitable ion for these two tests. Now, in this question, small amount of aqueous ammonia solution was added, okay, to the aqueous solution containing zinc ion. A white precipitate was formed. So then he's asked you what's the equation for this reaction. As you can see there, for part A, zinc with water. Okay, the water here is the ligand and it is reacted with ammonia. He's asking you which equation for this reaction. Since the small amount of aqueous ammonia, this means that it is not in excess, okay, because in the first one, you will see that the zinc here will form positive 1 ion. So this is wrong because the total charge must be not positive 2. So this is wrong because you have hydroxide. So the first choice is wrong. For the second one, there is a formation of a precipitate and there is no ion and the total charge is 0. So this one is correct one, but the others, there is a kind of ligand exchange and water is formed and there is a soluble substances. In the last one, D, you will see the zinc, okay, she'll have positive 2 there, but it is with white precipitate. So the mistake is that it should be like that, positive 2, because you have 2 neutral substances and not a precipitate. So that's why B is the correct answer. Now, for question 6, acidified manganate 7 ion reacts with ethane diowate ion. According to the following equation, the rate of this reaction increases, then decreases. What are the reasons for these changes? It increases, then decrease in the rate of the reaction. The reason for the rate increases because the manganese positive 2 ion works as a catalyst, and since so A or B is the correct answer, but for the second one about the rate, since the kinetic energy of the particles decreases, so what's the correct answer is B, because the concentration of the reactants was decreased and that's why the rate decreases with time. So B is the correct answer. The correct answer is B. Now, what's next? Question 7. Here, E-node cell, it's the standard electrode potential for the cell. He is asking you, it is directly proportional to the delta H of the reaction and ln K. It is the delta H of the reaction and ln RT. It's the delta S total and ln K, delta S total and ln RT. So it will be C because it is directly proportional to the delta S total and the K constants or the ln of K. Now, Why? Because it is not related with the enthalpy change of the reaction in A and B, and delta S total and ln RT, those are constants, and the R is constant, and it is not changed to change the equation. Now, for question 8, standard electrode potential can also be given an alternative name. The electrochemical series lists standard electrode potentials in order. Which of these is correct? The alternative name for the standard electrode potential, it is a standard reduction potential. So these two terms are correct, the first one and the second in A and B, but it is not considered as cell potential because the E node cell is what is called E cell potential. So C and D was cancelled. What is left, A or B? Order of standard electrode potentials in the electrochemical series, most negative to most positive. It is the most positive to the most negative. Since he is asking you about the standard reduction potential, so it is the standard reduction potential that's considered to be 0, which is for hydrogen, and you will see it is from the most negative to the most positive. Since the order of a standard electrode in the electrochemical series, it's from the most negative to the most positive. That's why it is A. Okay. Next one. The half equation for the reaction taking place at the positive electrode in the alkaline hydrogen oxygen fuel cell is O2 plus 2 water molecules and 4 electrons to produce 4 hydroxide molecules or polyatomic. What's the half equation for the reaction taking place at the negative electrode? As you will see 4 equations, okay, where the hydrogen, the first one you will see hydrogen is used with hydroxide to form water. Since this one is reduction, so the oxidation is what is needed for the second equation. All these equations, they are oxidation equations. And because in the question it is in alkaline solution, the alkaline solution is very important there, since okay, the alkaline solution is very important because the alkaline solution will react with hydrogen in these 3 equations. That's impossible to be formed. So the most correct answer is A, because it is the oxidation of hydrogen to water in the presence of hydroxide ion. But the other 3 equations, they will not be formed in the alkaline solution because the alkaline will react with hydrogen and reverse the equilibrium to form water in the other side. So that's very, very important. Okay, now for next question, question 10. The electromotive force E node cell of the cell is positive 0.57 volts. The the numerical values of the standard electrode potential of the two half cells joined in this cell are positive 17 and positive and 0.4. What are the signs of the standard electrode potential of the right hand half cell and the left hand side cell? To calculate the E naught, we use this equation. E naught, it's the E right hand minus E to the left hand one. So to get the sign, so it will be positive. So this means that we have 4 positive minus 17.17, sorry, 0.4, okay, plus positive 17. So this positive in the right hand half cell, it will be positive, and negative for the left hand side. So in the left hand half cell, it will be negative, and for the right hand cell it will be positive. So the correct answer is B. Now, for next question, an electrochemical cell is set up. Half cell is made from a piece of zinc and solution of zinc chloride, ZnCl2. A second half cell is made from a piece of metal G and solution of its chloride, GCl2. The two half cells are connected and the current allowed to pass for some time. The zinc electrode increased in the mass by 1.635. That's the zinc electrode was increased, okay. And the electrode of G decreased in the mass of 0.6075. What's the metal GS? Okay, it's very easy, because if you find out, look, if you find out what's the mass that's increased for zinc, it is what's the moles, sorry, of the zinc. So this will give you 1.635 over the molar mass of zinc, which is 65.4. 65, sorry. So it is 65.4 grams per mole. And this will give you how many moles? It will give you 0.025 moles. Now, This 0.25 moles, they are the same for how much G was increased, and he gave us the mass. You know, the number of moles equals the mass over the molar mass. And from this equation, we can find that the molar mass equals the mass over the number of moles. So if you divide 0.6075 over the number of moles, which is 0.25, this will gives you 24.3, okay, grams, which is the molar mass of the element magnesium. That's why the correct choice is magnesium. Now, for next one, which of these is the weakest base? Okay. Here you have an important thing. Okay. Let's talk about the ammonia. Ammonia has this structure, and it has two lone pairs, which they are donated without any delocalization. For butyl amine, it's CH3, CH2, 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 and H2. And we have also two paired electrons, but the alkyl group is electron donating group, and it will give. He is asking which one is the weakest. Ethylamine is the same story, and they will give or donate electrons for the amine group, but for phenylamine, what's the idea is? Here we have ring, and for this we have two lone pairs, which they share the delocalization of electrons, which makes these two electrons not easy to be donated for the external electron acceptors. That's why the weakest one is the phenylamine, because the definition of the base is that one which donates the two electrons, or it can accept the hydrogen ion by donating these two electrons. If they are more bonded by the idea of the delocalization, this makes the phenylamine is the weakest base in the question. Now, for the amino acids, two amino propanoic acid exists as deuterionic at pH 6. What will be the structure of two amino propanoic acid at pH 9? Okay, look there. At pH 9, it's basic. So the ion will receive the hydrogen, or the hydrogen ion, or the proton. So this makes that the first one is the neutral one, okay, and the second one is that one which is negatively charged, so it can receive the hydrogen ion. So it is in basic form. That's why this is the most correct answer For the second one, it's the acidic. For C, it's the acidic one. And for the next one, it has 2 charges, which is wrong. So this is wrong, but what's correct is answer B. Okay, let's go further. An organic compound, Je, reacts with sodium hydroxide to form ionic compound. Hydrogen in the presence. So it has what? Acidic. This means that it has acidic characters. It has carbon-carbon double bond there, and ethanol in the presence of sulfuric acid. Maybe it's an acidic or carboxylic acid group, so it will contain this. The compound which contains all these facilities or these properties is A. So A is the correct answer. Now, for next one, question 15, a reaction scheme for the preparation of an azo dye is shown. Do you remember the diazonium salt? In step 1, step 2, then step 3, then the intermediate, and here we predict that we have more than one question about this type of question. In step 1 takes place using a mixture of concentrated nitric acid and concentrated sulfuric acid at what? At 55 degrees. Why is the reaction not carried out at 80 degrees? At 80 degrees, this makes more nitration, a lot of nitrations. So further substitution by nitro group will take place, not because the nitrobenzene decomposes and not by the substitution of SO3 occurs, because here desulfurization is taking place and the nitric acid can decompose at 80 degrees. The most important idea to prevent the further substitution of the product or of the reagents. How is step 2 carried out? Is it by SN concentrated HCl, or is it by 10 in the presence of dilute HCl and sodium hydroxide are added together, or it is concentrated HCl added first, then it is added, then the sodium hydroxide, is added at the end. SN is dilute HCl or 10 in the presence of dilute hydrochloric acid as added first, then sodium hydroxide is added at the end. Here you shall memorize the conditions for step 2 there after nitration. So the correct answer is C. Oops. So that's the correct answer. Now, the next one. In step 3 takes place using sodium nitrate, okay, and dilute hydrochloric acid at 5 degrees. What is the structure of the intermediate? Again, if you return back to the structure, you will find that the correct answer is C. That's the diazonium salt, because there is no triple bond there and Cl not combined with the structure or not doing what's known as a covalent bond with the structure. The reaction or the reactant in step 4 is phenol. What conditions is needed? It's very important to know that the conditions for this reaction is alkaline condition, and that's what's needed for this equation. Sorry. We have what is left? We have two questions, which they are 16 and 17. Okay, for question 16, 10 cubic centimeters mixture of methane and argon is ignited. The methane requires 4 cubic centimeters of oxygen for complete combustion. What is the volume of argon in cubic centimeters in the mixture? Okay, and all volumes are measured at the same temperature and pressure. Look, first of all, you have 10 cubic centimeters of methane, which is the organic, and you shall write the equation. Methane reacts with oxygen to form CO2 plus H2O. Let us balance the equation. Is here we have 2 multiplied by 2 for water. We have 4 hydrogens, but we have 2 oxygens. The methane requires 4 cubic centimeters of oxygen for complete combustion. What is the volume of argon? 10 cubic centimeters are mixture of argon and methane. Okay? So, what is reacted according to the equation, since here we have 4 cubic centimeters, so 4 divided by 2, this means that we have 2 cubic centimeters of methane was reacted. So 10 minus 2, what is left? 8 cubic centimeters of argon, which is left. Next question. When 10 cubic centimeters of butane C4H8 is ignited with excess oxygen, there is an overall decrease in the volume of X cubic centimeters. All gases' volumes are measured at room temperature and the pressure. This is the equation. A further decrease of Y cubic centimeters takes place on the addition of aqueous sodium hydroxide as carbon dioxide is removed. What are the values of X and Y? Now look, here we have C4H8 reacted with what? With 6O2. You know, if we have 10 cubic centimeter, those are consumed. And here we have what? 40 cubic centimeter, which is produced. So it seems like 40 cubic centimeter was produced and 10 cubic centimeters was consumed. So 30 is the value of X, which is the total volume decreasing. But if this is correct, not all the other answers are correct, since the further decrease by sodium hydroxide, this is to remove acidic oxide. The acidic oxide is CO2. So because CO2 is acidic oxide, it can be removed by sodium hydroxide. So what is removed from the reaction is excess 40 and not 80 because because also water is a liquid at standard temperature and pressure. Not all gases was removed. Only what is removed is 40 cubic centimeter of what? Of carbon dioxide. That's the first part of this paper, the multiple choice questions. Take care. Make an assessment for yourself if you can do them again. So please print them and try to solve them with a good explanation like how I explains. That's me, Bishr Samhan, your chemistry teacher. Thank you very much.